Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the polymers, plastics and rubber. The weightage of polymers in ECET examinations is 3 marks. Initially, let us discuss about the polymers. Polymers are macromolecules having high molecular weight and are simply formed by the condensation of large number of small molecules. Coming to the good examples of polymers, it includes polyethylene, polyvinyl chloride, polystyrene, proteins, rubber, cellulose, starch, etc. Let us see the formation of polyethylene. Polyethylene is obtained by the polymerization of large number of ethylene molecules. Let us consider ethylene. Its structure is CH2 double bond CH2. During the formation of polyethylene, breaking of this double bond takes place. With the result, two bonding sites will be generated and hence more and more ethylene molecules will join on either side of the molecule, which results in the formation of a polyethylene. Is it clear about the formation of polymers? In the similar way, let us see how a polystyrene can be obtained. So, for the formation of polystyrene, we have to consider styrene as the monomer. Simple molecules are called as the monomers. So, coming to the styrene, it can be considered as the derivative of ethylene, which is obtained by the replacement of one of the hydrogen by the benzene nucleus. So, it is CH2 double bond CH C6H5. It undergoes polymerization in the similar way as like that of ethylene. Breaking of this double bond takes place and with the result two bonding sites will be generated and hence more and more number of styrene monomers can be added. With the result, it results in the formation of a polystyrene polymer. Let us see what is meant by a monomer. Monomer is a simple molecule with two or more bonding sites. So, what is the requirement of a simple molecule to act as the monomer, students? A simple molecule is supposed to have at least two bonding sites. How to identify the bonding sites in the given molecules? Let us see few examples. Here we are having ethylene. So, in ethylene, a double bond is present. Breaking of this double bond results in the formation of two bonding sites. So, ethylene can act as a monomer. So, there are two possibilities for a simple molecule to act as the monomer. So, a simple molecule is supposed to have at least one double bond to generate two bonding sites. Is it clear, students? Let us see vinyl chloride. Here also a single double bond is present. With the result, what happens, students? Two bonding sites can be generated. So, a simple molecule with at least two bonding sites can be called as a monomer. So, these molecules can be called as the monomers. In the similar way, there is another possibility for simple molecules to act as the monomers. On the other hand, a simple molecule having at least two active functional groups can act as a monomer. Active functional groups means they are ready to participate in a chemical reaction, which generally includes hydroxide group, acid group, amine group, chloro group. Even the presence of sodium will make the molecule to participate in a chemical reaction very easily. Let us see one example. It is glycol. How many hydroxide groups are present? 2. So, there is a possibility to participate in a chemical reaction at two bonding sites. So, this glycol can act as a monomer. Why? Here, the molecule can start a chemical reaction from two areas. So, it is bifunctional. Hence, it can be considered as a monomer. So, simply how to identify a monomer? A simple molecule is supposed to contain at least one double bond, or it may contain at least two active functional groups, then they can act as the monomers. Let us see few more examples. Here in this case 1,3-butadiene. So it is having two double bonds. So at least one double bond is enough to act as a monomer. So it is a monomer. But coming to the other molecule, it is ethyl chloride. No double bond is present and it is not at all having two active functional groups. So ethyl chloride cannot act as a monomer. In the similar way, we can see other examples. It is ethylene chloride. So here also two active functional groups are present. Hence it is a monomer. And coming to the diacid, here also two active functional groups are present and hence it can act as a monomer. But coming to the ethylamine, it is having only one active functional group, so it cannot act as a monomer. Is it clear about the monomers, students? So how to define a monomer? A monomer should contain at least two bonding sites. Then only that molecule will called as a monomer. Clear, students? Next, let us see what is meant by functionality. Functionality means the number of bonding sites present in a monomer is called as functionality. Students, what is meant by functionality? The number of bonding sites present in a monomer is called functionality. Let us see few examples. In the case of ethylene, how many bonding sites are present? Two bonding sites are present and hence it is bifunctional. So here the functionality is 2. Coming to the glycol, here also two active functional groups are present and hence this monomer is also having two bonding sites and hence functionality is 2. Coming to this example, here three active functional groups are present and hence the functionality is 3. Coming to the last example, here two double bonds are present and hence the functionality is 4. Is it clear about the functionality, students? Functionality means the number of bonding sites present in a monomer is called functionality. And the next important term is degree of polymerization. So coming to the degree of polymerization, it can be defined as the number of repeating units present in a polymer. So what is meant by degree of polymerization, students? The number of repeating units present in a polymer. Let us see one example. It is the polyvinyl chloride. Let us see how many vinyl chloride molecules are present. This is the first molecule. It is the second one, third one, fourth one, and it is the fifth one. So how many times the vinyl chloride is repeated in polyvinyl chloride? It is repeated 5 times and hence the degree of polymerization of polyvinyl chloride in this case is equal to 5. Or simply without seeing the structure, it is possible to calculate degree of polymerization by knowing the molecular weight. So degree of polymerization is equal to molecular weight of the polymer divided by molecular weight of the monomer gives degree of polymerization. Is it clear about the degree of polymerization? So degree of polymerization means the number of repeating units present in a polymer. Let us discuss about the classification of polymers. Polymers are being macro in size. They can be classified in many ways. So coming to the classification based upon the source, that means based upon the availability, they can be classified into two types: natural polymers and synthetic polymers. So natural polymers means they are available in the nature. Good examples for natural polymers includes cellulose, starch, proteins, rubber and nucleic acids. Coming to the synthetic polymers, they are man-made polymers or they are prepared in a laboratory, which generally includes polyethylene, polyvinyl chloride, polystyrene, bakelite, etc. That is about the classification based upon the source. Coming to the classification based upon the molecular forces. So whenever if we consider polymer, it consists of number of polymer chains. So based upon the molecular forces that are existing between the polymer chains. So generally polymers consist of number of polymer chains. So depending upon the force of attraction between the polymer chains, all the polymers can be classified into four categories. First one being thermoplastic polymers. Thermoplastics means they softens on heating and hardens on cooling. So those polymers which softens on heating and hardens on cooling are called as thermoplastics. They generally includes polyethylene, polyvinyl chloride, polystyrene, Teflon, etc. Coming to the second category, it includes thermosetting polymers. Thermosetting polymers means they do not soften on heating once they have solidified into a hard mass. So after preparing an article, it is not possible to soften the thermosetting polymer by applying the heat. Is it clear about the thermosetting polymers? They includes polyester, bakelite, etc. as the good examples. Coming to the elastomers, elastomers are rubber-like materials. That means they exhibits elasticity. Elasticity means they can be stretched at least thrice its length and it will return to its original shape as soon as the stretching force is released. So elastomers are synthetic rubbers. That means they are rubber-like molecules. They can be stretched at least thrice to its original length. Good examples for elastomers includes Buna S rubber, Buna N rubber, etc. Coming to the fibers, in fibers, strong intermolecular forces are present. Strong intermolecular forces such as hydrogen bonding will be present in fibers and hence they exhibit enough strength and stiffness. Good examples for fiber includes nylon and polyester. Is it clear about the classification of polymers depending upon the molecular forces, students? Let us discuss about the polymerization. Coming to the polymerization, it can be defined as the process in which several monomers combine to form a polymer. So the process by which monomers combine to form a polymer is called polymerization. So good examples includes polyester, polystyrene, Teflon, bakelite, etc. Let us see the formation of Teflon. Teflon can be prepared by the polymerization of tetrafluoroethylene. So tetrafluoroethylene molecules undergoes polymerization and that results in the formation of Teflon. Coming to the types of polymerization, polymerization can be classified into two types. One is addition polymerization and the other one is condensation polymerization. Addition polymerization is also called as chain polymerization. As it follows chain mechanism, it can be called as chain polymerization and it is a rapid process. So in this addition polymerization, the monomer molecules combine to form a polymer and there will be no elimination of simple molecules. Let us see the formation of polypropylene. So try to remember the structures of monomers as the derivatives of ethylene. So what is the structural formula of ethylene? CH2 double bond CH2. You remove one hydrogen and substitute methyl group. Then it will be called as polypropylene. So breaking of this double bond results in the formation of polypropylene. So in addition polymerization, no simple molecules will be eliminated. Simply the monomers will join, that results in the formation of a polymer. In general, the catalyst used for addition polymerization is dibenzoyl peroxide. Students, is it clear about the addition polymerization? In addition polymerization, what happens? Simply the monomers join to form a polymer. It follows the chain mechanism and it is a rapid process. Coming to the condensation polymerization, it follows stepwise mechanism and hence it is also called as step polymerization. Especially the monomers having functional groups participates in condensation polymerization. In this condensation polymerization, always a chemical reaction takes place between the functional groups of the monomers, and hence the formation of polymer involves the elimination of simple molecules. So that's why this step polymerization is a slow process. Let us see few examples. Generally, the formation of nylon 6,6 polyester bakelite follows the condensation polymerization. Let us see how a nylon 6,6 will be formed. During the formation of nylon 6,6, two monomers are present. One is diamine and the other one is adipic acid. So, amine group from diamine reacts with the acid group of adipic acid and it results in the formation of nylon 6,6. Nylon 6,6 generally contains amide as the functional group and hence it can also be called as a polyamide. Is it clear? So what is the other name for nylon 6,6? It is also called as a polyamide polymer. This is the polymer which contains nitrogen in the main chain of the polymer. Is it clear about the condensation polymerization, students? So during condensation polymerization, what happens? The functional groups of the monomers participates in a chemical reaction and that results in the formation of a polymer with the elimination of simple molecules. Let us see one more example. Formation of bakelite is very important. It is a thermosetting plastic. So bakelite is good example for thermosetting plastic. So this bakelite can be formed by the condensation polymerization and it involves how many steps? It involves 3 steps. In the first step, phenol reacts with the formaldehyde in the presence of an acid that results in the formation of ortho and para hydroxymethyl phenol. So, what are the monomers used during the preparation of bakelite? Phenol and the formaldehyde. In the second step, orthohydroxymethyl phenol undergoes polymerization and it results in the formation of novolac. So in the second step, what happens? Orthohydroxymethyl phenol undergoes polymerization and that results in the formation of novolac. And finally, in the third step, novolac undergoes polymerization in the presence of hexamine as the catalyst and finally it results in the formation of a bakelite, and this bakelite is having cross-linked structure. So what is the structure of bakelite? It is having cross-linked structure. Is it clear about the preparation of bakelites? And we are going to discuss about a special type of addition polymerization and that is called as copolymerization. Copolymerization means generally this polymerization involves the use of two different types of monomers. So whenever addition polymerization is done by using two different types of monomers, it can be called as a copolymerization, and the polymer obtained is called as the copolymer. And the best examples are Buna S, Buna N, etc. Let us see the formation of Buna S rubber. It can also be called as GRS, Government Rubber of Styrene. So, what are the monomers used in the formation of Buna S rubber? Here we are using two monomers. One is 1,3-butadiene and the second one is styrene. So, the monomers used during the preparation of Buna S are 1,3-butadiene and styrene. Here, the polymerization takes place in the presence of sodium as the catalyst. So, in Buna S rubber, Na stands for Na used as the catalyst. That means sodium is used as the catalyst. So, coming to the polymerization, initially the previous double bonds will be broken and it results in the joining of two monomers. Hence, finally, Buna S rubber can be obtained. Is it clear about the copolymerization, students? So, during copolymerization, what happens? Two different types of monomers undergoes addition polymerization and that results in the formation of a copolymer. Good example is the formation of Buna S rubber. Let us discuss in brief about the plastics. Plastics means they are completely organic polymers. Generally, 95% of polymers are organic in nature. Coming to the plastics, they are high molecular weight organic polymers which can be molded to desirable shapes by the application of heat and pressure. So, the materials which can be molded to any shape simply by applying heat and pressure are called plastics. In general, the raw plastic is very soft in nature and it can be called as the resin. So, in order to improve the properties of the plastics, generally compounding of plastics can be done. So, compounding of plastics means it is the process in which several chemicals are added which results in the formation of a homogeneous mixture with improved workability. So, the process of including various ingredients into the raw plastic with improved workability is called compounding of plastics. Let us see what are the chemicals used during the compounding of plastics. First one is binder. Second one is fillers. Third one is plasticizers, stabilizers, colorants, catalyst and lubricants. Coming to the binders. Binders means what is the purpose of binder? It holds all the ingredients present in the plastic together. And the best examples includes cellulose derivatives. Coming to the fillers, they are mainly used either to reduce the cost of the plastic or to improve the tensile strength of the plastic. Good examples are asbestos powder, clay, wood floor, quartz, carborundum, etc. Coming to the plasticizers, the very purpose of the plasticizers is it improves the flexibility of the plastic, and vegetable oils and camphor are the good examples. Coming to the stabilizers, they impart thermal stability. Good examples are white lead and red lead. Coming to the colorants, they impart beautiful colors to the plastic. Generally, titanium oxide, barium sulfate gives white color, ferric oxide gives yellow color, carbon black imparts black color. Coming to the catalyst, what is the importance of catalyst? They accelerate the rate of the reaction. Generally, peroxide will be used as the catalyst. Hydrogen peroxide, benzoyl peroxide, even silver will act as a good catalyst. And finally, coming to the lubricants, lubricants are mainly useful to make the fabrication process easy. So, the importance of lubricants is it makes the fabrication process easy. The good examples are waxes, oils, soaps. This is about the compounding of plastics. Is it clear about the compounding of plastics, students? Next, we will discuss about the rubbers. Rubbers means they are the long chain polymers and they exhibits elasticity. Elasticity means they can be stretched at least thrice to its original length. So that means the polymers which can be stretched at least 3 times to its original length are called as rubbers. That means we can improve its length by 300%. And generally the natural rubber exhibits 4 to 10 times stretching when compared with the synthetic rubber molecules, and this elasticity is mainly due to its structure. So rubbers are having coiled structure. So what is the structure of rubber molecules? They are having coiled structure. So whenever if we apply stretching force, what happens? The coiled structure will try to straighten out. That's why the length of the elastomers increases when stretching force is applied. And these rubbers are amorphous in nature. And from where these rubber molecules can be obtained, that means coming to the sources of rubber, rubber can be obtained from rubber plants in the form of a latex. So rubber is obtained from rubber plants in the form of latex. Generally, latex contains 25 to 45% of rubber. So, always this latex is associated with so many impurities. That's why processing of the raw rubber should be done. So, during the processing of raw rubber, they will follow 4 steps. First one is dilution. Second process is coagulation. Third one is filtration, and it is followed by the drying process. Coming to the dilution, initially the latex is diluted in such a way. Diluted latex contains only 15 to 20% of the rubber. And in the second step, the coagulation is done. For coagulation of diluted latex, they will use acetic acid or formic acid as the chemicals. So, during coagulation, a coagulum will be obtained. So, coagulum is filtered and it is followed by drying process to get the raw rubber. Is it clear about the processing of raw rubber, students? Coming to the latex, it contains isoprene. So, what is the monomer present in the latex? That is isoprene. So, during the processing of raw rubber, chemically, the isoprene undergoes polymerization. So, what is the chemical name of isoprene? It is 2-methyl-1,3-butadiene. So, during processing, what happens? This isoprene undergoes polymerization and it results in the formation of rubber. So rubber is also called as polyisoprene. So what is the monomer of natural rubber? Isoprene is the monomer of natural rubber. During polymerization, there is a possibility for the formation of cis isomer or trans isomer. Cis isomer means if the similar groups are present on the same side of the double bond, that isomer is called as cis isomer. Natural rubber is a cis isomer. On the other hand, if the similar groups are present on the opposite side of the double bond, the isomer is called as trans isomer. Trans isomer is generally known as gutta-percha rubber. So what is the name of the trans isomer? It can be called as gutta-percha rubber, and this is very important. Why? This gutta-percha rubber is used by dentist for temporary filling. So what is the importance of gutta percha rubber? It is used by the dentist for temporary filling. Natural rubber is the cis isomer, whereas gutta percha rubber is the trans isomer. Is it clear about the processing of natural rubber? So isoprene is the monomer present in the rubber molecules. As like that of plastics, the raw rubber is also soft in nature. So the properties of raw rubber can be improved by compounding of elastomers. So compounding of elastomers includes the use of fillers, plasticizers, reinforcing agents, antioxidants and colorants. Coming to the fillers, they are mainly used to improve the strength of the elastomers. Good examples are carbon black and graphite. Plasticizers are mainly added to improve the flexibility of natural rubber. Good examples are vegetable oils and waxes. Coming to the reinforcing agents, they are added to elastomers to impart toughness to the elastomer. Good examples are magnesium carbonate, calcium carbonate and zinc oxide. Coming to the antioxidants, they must be added in very little proportion, that is 1%. The purpose of antioxidants is they prevent breakage of the rubber molecules. Good examples are phenyl naphthylamines and phosphates. Coming to the colorants, they impart pleasing colors to the rubber. Titanium oxide gives white color, whereas carbon black imparts black color. And in addition to these chemicals, there is one important chemical, that is sulfur, which imparts strength and stiffness to the raw rubber. So among all these chemicals, sulfur is very important during the compounding of elastomers, and the process of including sulfur to the raw rubber is called as vulcanization. So what is meant by vulcanization? It is the process of treating raw rubber with sulfur at 140 degrees centigrade. And what is the purpose of vulcanization? It imparts strength and stiffness to the natural rubber. And the process vulcanization was introduced by Charles Goodyear. Who introduced vulcanization? Charles Goodyear. So let us see vulcanization process in detail. So generally the rubber molecule consists of double bonds in their structure. Let us consider two rubber molecules. So whenever the raw rubber is treated with sulfur at 140 degrees centigrade, simply sulfur is added at the double bond position. So at the double bond position, during vulcanization, what happens? Sulfur will be added. With the result, the flexibility of the raw rubber will be prevented. That means vulcanization imparts strength and stiffness. Generally, during the manufacturing of tire rubber, they will add 3% rubber. 3% sulfur to the rubber. And during the preparation of ebonite rubber, they will add 33% of sulfur to the raw rubber. So during the manufacturing of tire rubber, how much percentage of sulfur will be added? 3% sulfur will be added. For the preparation of ebonite rubber, 33% of sulfur will be added. Finally, we will discuss about the monomer, what type of monomers are used in the polymer, and what are the uses of the polymers. And the first polymer is polythene. It is obtained from ethylene. So what is the monomer present in polythene? Ethylene. And what are the uses? It is used for domestic appliances, for the preparation of toys and packing materials. Coming to the polyvinyl chloride, The monomer present in polyvinyl chloride is vinyl chloride, and the applications are, they are mainly used for the preparation of raincoats, curtains, safety helmets. Polystyrene mainly contains styrene as the monomer, and polystyrene is used for the manufacturing of combs, lenses and optical equipment. Coming to the Teflon, Teflon is prepared from tetrafluoroethylene. So what is the monomer present in Teflon, students? It's tetrafluoroethylene. And what are the uses of Teflon? Teflon is mainly used for the preparation of gaskets, chemical carrying pipes. Coming to the polyester and nylon 66, both are used in textile industry, and especially the polyester is prepared by using two monomers. One is ethylene glycol and the other one is terphthalic acid. What is the brand name of polyester? Decron, or it can be called as terene. Coming to the nylon 66, it can be prepared by using diamine and adipic acid as the monomers. Coming to the Buna S rubber, it can be prepared by using 1,3-butadiene and styrene as the monomers. It is also called as GRS rubber, that means government rubber of styrene. Buna S rubber is mainly used for the manufacturing of tires and also footwear components. Coming to the Buna N rubber, it is also called as GRA, that means government rubber of acrylonitrile. The monomers used are butadiene and acrylonitrile. And coming to the applications, they are mainly used for the manufacturing of automobile parts and also aircraft components. Coming to the neoprene, it is also known as polychloroprene or GRM. That means government rubber of monovinyl acetylene. The monomer present in neoprene is chloroprene. It is mainly used for the manufacturing of aprons, gloves, bags, etc. Coming to the thiacol, thiacol is very important because it is the only rubber which cannot be vulcanized. So the only rubber which cannot be vulcanized is thiacol. It is also called as GRP, that means government rubber of polysulfide. It can be prepared by the polymerization of ethylene chloride and polysulfide. Thiacol is mainly used for the manufacturing of gaskets, life jackets, horses, etc. Coming to polyurethane, it can be called as government rubber of polyurethane, and it can be prepared by the polymerization of ethylene glycol and ethylene diisocyanate. The importance of polyurethane is it is used for the manufacturing of pillows, carpets, mats, etc. Coming to the butyl rubber, it can be called as GRI, that means government rubber of isobutylene. It can be prepared by the polymerization of isobutylene and isoprene. The importance of butyl rubber is it is used for the manufacturing of bicycle and automobile tubes. And finally, coming to the bakelite, it is the thermosetting plastic which can be prepared by the polymerization of phenol and formaldehyde. Coming to the applications, especially switches, switchboards, buttons, sockets can be prepared from bakelite. It is the thermosetting plastic and it is the first plastic synthesized in the laboratory, whereas Buna S is the first elastomer synthesized in the laboratory. Is it clear about the polymers containing different types of monomers along with their applications? Is it clear about the polymers, plastics and rubbers, students? If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.